What happens when you design a car that's as quiet as a library? You get this, the Lexus LS 460. In fact, it's so quiet that the likes of even the Yakuza use it as a form of transport to poodle around in as a rear passenger. For this week's Automotive X-Ray, we're gonna try and answer one question. How have they made this Lexus so quiet? The short story, lots and lots of sound deadening material which was added on top of the already very quiet Lexus LS 430, a more rigid and aerodynamic body so that you don't hear any weird vibrations, world-class suspension, and a powertrain that's so smooth you could put a wine glass on top of the engine. With that being said, let's unravel why the LS 460 was 2007's World Car of the Year. Have you ever stepped into a library and wondered why it was so quiet? Well, adding acoustic panels on the walls and the ceiling helps to absorb all of that noise and vibration from outside. How would this apply to a LS460, you might ask? To reduce engine noise, sound insulation is added to the engine cover, and to reduce road noise, Lexus pretty much added more and more sound deadening everywhere, such as a revised noise insulating structure to the tibia pad, sound deadening under the rear seat, thicker insulation to the front wheel arches, a change in rear wheel arch liner insulation material, and more sound insulation in the boot. And it doesn't stop there. Both wind and road noise have been reduced through adding more sound deadening to the door inner weather strips and service hole covers, as well as changing the insulation material for the roof trim and smoothing out the A-pillar and door frame moldings. But that's still not all. They even added sound deadening to the wheels. Yep, the wheels. The first time any Lexus ever used noise reduction wheels. Basically, these wheels channel tire noise into hollow areas inside the wheels, so this noise is basically gone as it's turned into kinetic energy. And with that, let's go over the LS460's chassis and aero. Before we harp on why this car's chassis is so good, have you ever wondered why older cars feel more raw compared to modern cars? Take the NA Miata for example. With the chassis rigidity of a wet noodle, it lets in all of these vibrations, which is why these are some of the most raw driving experiences on sale on the used market. Now, back onto the LS460. While the LS430 was already very rigid, Lexus decided to use forged aluminium for the suspension links, front steering knuckles, and rear hub carriers. But the biggest change Lexus made was using loads of high precision laser welding in its body structure to increase joint rigidity between panels and improve the damping, which we will go over in the next section. Laser screw welding joins a larger panel area than traditional welding, and using body adhesives to join the entire area where panels meet maximizes the rigidity of the joints. For the rest of the chassis, ultra-high tensile steel made up 40% of the steel body components, while aluminium was used on the body assembly, front and rear crash box structures, and a new die-cast single-piece front subframe. Let's move on to the aero. Why do we need good aero for a luxury car? One simple reason, high speed stability. Often, these cars are used on freeways like the Autobahn, where you're traveling at speeds of 150 miles per hour and over, so we don't want a car that constantly requires you to steer it due to it feeling too unstable. Let's deconstruct this a bit deeper in engineering terms. In fluid mechanics, there are two types of flow we look at, laminar and turbulent. Any car on the freeway is going to have turbulent flow acting on its body, so you have to smoothen out what we call the turbulent boundary layer, which is the thin layer of air flowing on the surface of the car. Reduce this and you now have a smaller wake, making the car more stable. To reduce this turbulence, Lexus have used Aero stabilizing fins mounted at the base of the door mirrors and at the sides of the rear combination lamps so that air flows smoothly down the sides and cleanly away from the rear of the vehicle. Also, adding these fins in places like the engine undercover and boot undercover meant that the LS460 has a drag coefficient of just 0.26 CD, which is the lowest in its class, as well as a front coefficient of lift of just 0.02. Fun fact, its rear coefficient of lift of 0.01, which is another huge reason why it feels very stable even during high-speed cornering. Is actually 0.06 lower than its closest competitor. And speaking of stability and smoothness, let's dive deeper into why the LS460 has world-class suspension. To fully understand how insane it is that the LS460 is the first vehicle within the premium segment to use a multi-link suspension all round, let's touch on double wishbone suspension for a second. Luxury cars usually offer this setup over McPherson struts, as the top wishbone is shorter than the other, and when the suspension is compressed, you get negative camber, meaning more grip and traction through that corner. Whilst the LS430 already had a great double wishbone front end, they decided to replace it anyway with a dual joint multi-link design so the headlink is even more poised and stable. Think about this for a second. In an era where McPherson struts were becoming the norm, Lexus still poured in the time and money to develop that sophisticated of a front suspension setup. And for the rear suspension, whilst double wishbones are actually quite good compared to sophisticated multi-rig setups, they just don't handle as well. All of these meant that, according to Lexus, body roll has been reduced by 30% over the LS430. Reducing body roll is great in a luxury car, as when you're sitting as a rear passenger, your body doesn't anticipate the roll like a driver's body would. So reducing this number to as little as possible means those who are motion sick don't throw up their morning Weet-Bix before school. Besides the type of suspension, how did Lexus reduce body roll by this much then? By increasing the lateral rigidity of the air suspension bushings by 6%, as well as changing the rebound spring design to a non-linear progressive type. And the variable damping range has been expanded, helping to reduce body roll as soon as you turn the wheel. Lexus's all-round air suspension setup also used adaptive variable suspension system, which will slowly increase the damping the faster you go, so the ride still feels comfy even on pothole-littered roads. But you'll also have heaps of stability when you're going pretty quickly, as the system will continuously adjust the damping to both inner and outer shock absorbers through a bend. But that's not all. The car even automatically lowers itself when you're going fast, which is why it has near zero front and rear lift coefficients. Let's now delve into the LS460's ultra smooth powertrain. For this video, we're going to split this into two parts, and we'll start with the engine. First up, the 1UR FSE, which powers the LS460, uses a very rigid, thermally stable die-cast aluminium block, which was actually over square by design for a 94mm bore and 83mm stroke. All 1UR FSE blocks actually undergo X-ray inspection and a CT scan to ensure the engine block is transmitting as little vibrations through the chassis as possible. Fun fact, Lexus actually even checked the sound of the engine block itself during production. And to reduce vibration on the crankshaft pulley used a torsional rubber damper, and the crankshaft itself was a forged steel design with 6 balance weights so it rotates as smoothly as possible. The connecting rods were also forged so that there will be no side load vibration. Before we continue with why this engine feels so smooth to most LS460 owners, we'll quickly go over the power. It made 375 brake horsepower and 493 Nm of torque, meaning it produced 35% more power and up to 30% more torque than the outgoing 4.3 litre unit, while delivering greater fuel economy and lower emissions. Anyways, one of the biggest contributors to the 1UR FSE smoothness is the VVT-IE system itself, as if we look at the table on the screen, cylinders 1, 2, 3 and 6 had inlet and exhaust timing which was always 4 degrees retarded from the timing of cylinders 4, 5, 7 and 8. According to Lexus, this setup actually reduced vibration at idle, and with that we now need a gearbox that doesn't feel jerky and can absorb all the little vibrations. So what did Lexus do? Introduce the world's first mass-produced 8-speed gearbox. Before we have a look at why the gear ratios make this car such a quiet cruiser on the freeway, let's briefly go over how this was designed. Like the Lexus ISF, this uses the Aisin AA ADE Sport direct shift gearbox with sequential shift, which can lock up the torque converter from 2nd through 8th gears. However, this was the first car to ever use this particular gearbox. Here's the really interesting part. There are no soundproofing materials within this gearbox, as Lexus decided to test the entire drivetrain to ensure it operated less than 10 decibels, which is equivalent to normal human breathing. Now, if we look at the gear ratios, surprise surprise, they're exactly the same as the Lexus ISF. Despite using a very short first gear, its low final drive of 2.937 allows the LS460 to cruise efficiently at high speeds. But here's the great thing, in low gears from 1st to 4th, the short gearing means the LS460 can still accelerate pretty well, which explains its 0 to 100k time of 5.7 seconds despite the car weighing almost 2 tons curb. Let's now head into the concluding remarks. Overall, what are my thoughts on the LS460? It's honestly one of my favorite luxury sedans ever, especially when straight piped for the noise alone. Lexus have absolutely knocked it out of the park here, as the levels of engineering brilliance they reached is quite shocking, even compared to its German counterparts, which are frankly less reliable. If you've got any other cars you want us to conduct an automotive x-ray on, let us know in the comments. We apologize for the absence from YouTube for a while, as we've not only been caught up with difficult engineering assignments, but we've also been busy in the lab making adjustments to the x-ray format to make these videos better and better. Much love to you all, and I'll see you in a bit.